Hello friend, today we will discuss about the uh, new topic, that is group technology. This technology is a part of the computer integrated manufacturing system. So we have a same subject and this is a small part of that subject. And you can also refer all the lectures are available on the Engineering College Banswara YouTube channel. So you will find all the lecture not only for this subject or rest of the subject. Also you will find the lecture on the YouTube channel available on the name of Engineering College Banswara. So group technology is basically a very simple thing, but it impact more in the manufacturing line. You can see in this diagram we have lots of parts. Suppose we have 1,000 parts that any system has to be manufactured, and all the part has to be assembled together to make the machines. So now what we will do, in first figure you find that there are 100 parts and those are randomly distributed. So in second figure you can see that some similarities part, like in first figure we have chain mechanism, chain and sprocket mechanism, and in some part we have a spindle and shaft type arrangement. So and in one figure we have some bracket. So you can see in the first figure it is very difficult to identify the part, but in second figure you can apply the any system. If you have, suppose we want to apply the barcode system to this part to identify its proper location and the where actually this this part is machined. So this is basically group technology. We are grouping the part by identifying some similarities. In some case we are identifying physical dimension, shape. We will discuss later on, but it's a very simple thing. Group technology, or it is also known as GT, is manufacturing philosophy in which the part having similarities, it may be the geometry, manufacturing process function, are grouped together and to achieve higher level of integration between the design and manufacturing function of a firm or company basically. So you can see it's a very simple thing. It's a philosophy basically. Suppose we want to do the manufacturing on the lathe machine and milling machine, and we have arranged machine in sequence. Okay, now if we think that our part will move from lathe to milling, then again grinding, then again it comes to the lathe. But what we are doing here, we first initially identify the machining steps. Suppose we have a shaft with the different diameter, okay, and in different steps. Even some shaft has a keyway, or some shaft may have oil grooves. So it's a different thing, but the main physical shape is common. Now what we will do, we will group all the shaft together and make one group of family, part family basically. So this is all about the group technology, and this will reduce your actually machining time, and if suppose you want to find the exact location of the part, so it will reduce the time. The group of similar part is known as the part family, and the group of machineries used to process an individual part family is known as the machine cell. So simple thing that suppose we assume we have a 60 student in a class. Now we want to identify we want to create a group of the student. Now first you have to fix the criteria on which basis you want to group the students. Suppose you have identified that your parameter is height. Now what you will do, you will identify the range of the height, then you will create the group. This student should be fall into this group, and rest of the student fall in this group. The same philosophy is used while developing the group technology system. Here we are using the geometry and the manufacturing process functionality. We will discuss each and everything. Group technology emphasizes on part families based on similarities in design attributes and manufacturing. Therefore, GT contribute to the integration of CAD, computer design, and computer manufacturing. So, group technology is basically developed during the computer system, and which is basically integrated with the manufacturing system. Earlier, what people do, they design some system in somewhere. Okay, on the design department, they will send all the design drawing or part drawing to the manufacturing plant. Now some difficulties may create during the manufacturing process. Some part may not be manufacturable, so they will again send to the design department. Then you have to change some design so we can manufacturing this part. Now in a computer integrated manufacturing system, what we are doing, we are using the computer technology basically in the design as well as the manufacturing system. So it's a integration between the design and manufacturing process. Implementing group technology, there are two major tasks that a company must undertake when it implement group technology. First, they have to take care about identifying the part families. If the plant makes 10,000 different parts, reviewing all of the part drawing and the grouping the part into families is a substantial task that consumes a significant amount of the time. And second thing is rearranging production machine into cell. It is time consuming and costly to plan and accomplish this rearrangement, and the machine are not producing during the changeover. Group technology, there are 4 general methods for solving part families. All the 4 are time consuming and involve the analysis of much of data by properly trained person. The 4 method that normally we are using: the visual inspection, composite part method, production flow analysis, part classification and coding. So these mainly 4 methods that are used in the group technology to create the part family. We will discuss one by one. Now first is the visual inspection. Visual means you can see by the naked eyes that, or in that you don't have to take so much time to identify the part family. The visual inspection method is the less sophisticated and less expensive method. So in this you don't require any latest system to identify the part. It involves the classification of the part families by looking at either the physical part or their photograph and arranging them into the group having similar features. So you can see suppose you have this part, or you have a drawing of that part. Now you can easily identify that that part should be grouped together. First, in first figure you can see we have almost all the cylinder rod basically, and in some part we have a hole, in some part we have a thread, keyways, in some part we have grooves, taper also. So this part, all the parts should be together to create the one part family. In second figure you can see these part are circular part, but they have different features. One is like turbine, one is a flange, one is a rotor type. So these all are circular part, but in further, you suppose you want to create another part family, you can also identify the features. This is a very simple method. In second figure also you can see we have different shape. So suppose you want to create the group of this shape. In first shape you can see we have a three triangle. In second shape we have a three rectangle, but different dimension. The only thing main shape is the common. You can see only variation is the dimension. In third figure you can see is we have a three circle with the different diamond. And in last you can see we have a hexagon. Now moving towards the second method, that is the composite part method. In this method, hypothetical composite part is formed on the basis of the features of all the components forming the group in the question. Figure shows the number of components manufacturing on the lathe. So you can see this all the part that should be manufactured on the lathe. Various operations include setting length, facing, turning, growth, drilling, boring, reaming, counter, boring, chamfering, and parting off. So these are the common features that normally we are performing on the lathe machine. So how we can create the group? Suppose you want to do the manufacturing of this part. Each job needs all the operation. An imaginary component is composed which involve all the operation needed for the group. The tool setting is done for such component on a multi-tool setup. Setups a turret which can easily handle up to the 11 tools. Depend upon a particular component to be a work on, the instruction are prepared to indicate the tool and subsequence of the operation they have to be used. Whenever a new component is made, its group is determined and then its sequence of operation and the tooling is prepared. So you can see here we have different component and with a different size, but from the observation you can observe that all the parts should be manufactured on the lathe machine only. So here we are combining all the parts that we are creating the composite drawing. Now third is the production flow analysis. So this we will discuss in next lecture.